evening, ma'am. This is Divya Rajkumar along with my team members Heramb Patil, Rohnit Rathod, Harshita Phadtare, and Ojas Keer. We are from BTech IT and we have taken the topic Static and Dynamic Analysis for Secure Software Development. Abstract. Secure software development and the importance of combining static and dynamic application security testing. SAST scans the source code before execution to catch vulnerabilities early, while DAST tests the applications in runtime to find issues that appear during real world use. Together, they provide comprehensive security coverage. In addition, the DevSecOps approach integrates security into every stage of development, ensuring vulnerabilities are addressed proactively. We are also leveraging AI driven threat detection CI CD pipelines, which automates and enhances our ability to identify and respond to threats. In short, by combining these practices, we can build a secure, automated, and resilient systems to keep up with today's evolving cybersecurity threats.
Coming to introduction, in today's world where software is embedded in critical systems across healthcare, finance, and infrastructure, ensuring its security is more important than ever. Our work focuses on comparing and combining two key testing methods: static application security testing and dynamic application security testing, to create a more effective and reliable security framework. SAST examines the source code in the early stages of development, allowing developers to catch vulnerabilities before the code is executed. And on the other hand, DAST tests the application in its running state, identifying issues that arise only during the runtime. Each method has its own strength and limitations, but when used together, they provide a more holistic view of the software's security. Beyond this comparison, our project also dives deeper into how modern practices like DevSecOps and AI/ML driven threat detection can further enhance the security development by integrating automated security checkpoints into CI/CD pipelines and using intelligent tools like SonarQube and OWASP and AI models trained on vulnerability datasets. We enable continuous monitoring and real time remediations and smart prioritization of threats.
I'm Ojas and I'll be doing literature. Previous research has found the following findings. Previous research has looked at how SAST and DAST work well together to find security issues during different parts of software development. SAST checks the code early on and can spot problems before the software runs, but it sometimes gives too many false warnings. DAST, on the other hand, tests the software while it's running. It gives more accurate results based on how the app behaves, but it can miss some parts of the code. Studies by Abbas and Hafund show that using both methods together works better. At the same time, DevSecOps approach encourages ongoing security by using automation, teamwork, and adding security checks into the regular development and deployment process.
Coming to methodologies and the tools used, the four types of methodologies used are application testing, DevSecOps implementation, AI/ML augmentation, and feedback loop integration. The application testing is divided into two parts, static and dynamic. Static is basically white box analysis testing on code level vulnerabilities, whereas dynamic ones use tools such as OWASP and Burp Suite to check black box testing. DevSecOps implementation is basically CI/CD pipeline embedding with infrastructure as code and depends on tools like TFSec and Sync. AI augmentation is basically training an ML model on historical data sets to detect SQL injections and runtime anomalies. And feedback loop integration is unifying a dashboard results for all tools that provide actionable insights to and fro to developers to facilitate continuous learning.
Coming to the results and discussions, we observed that combining static and dynamic analysis provide a more well-rounded and effective security assessment. Static testing helped us catch code-level vulnerabilities early in the development phase, while dynamic testing uncovered issues that only appear when the application is running. When integrated into the CI/CD pipeline, these tests became automated and continuous, enabling developers to receive immediate feedback and fix issues in a real time. The use of AI and ML further enhanced this process by reducing false positives and intelligently prioritizing vulnerabilities based on their severity and exploitability. Overall, this layered approach not only improved detection accuracy but also streamlined the remediation process and made security more accessible for developers.
So the challenges and limitations are limited label data, that is high quality label data, vulnerability data set. What this means is as we rely more on AI and machine learning for sophisticated security analysis such as identifying complex vulnerabilities, we are hampered by a scarcity of comprehensive and well annotate data. This lack of diverse training data can significantly impact the accuracy and effectiveness of AI driven security tools, potentially leading to both missed vulnerabilities and false alarm. The second is tool fragmentation. Um, Tool fragmentation means in this, the security tools work in isolation and make the result correlation difficult. Consequently, the security analysts face the time-consuming and error-prone task of manually piecing together information to gain a holistic view of application security posture. Um, the third one is dynamic testing scalability. Dynamic testing scalability means it offers demand subsequential computational resources and execution time to conduct through tests. This can create a bottleneck in fast-paced development cycles, making it challenging to consistently and comprehensively assess the security of every build and release. The fourth one is adversarial imports. This makes it difficult to understand why a particular vulnerability was flagged, which can reduce trust in AI findings and complicate remediation efforts as teams struggle to grasp the underlying reasoning. The last challenges and limitation is security team must understand, that is explainable AI. Security team must understand the rationale behind the vulnerability identification to effectively prioritize, address, and ultimately trust AI insight, which basically means transparency in AI decisions is essential for adoption in security workflows. Thank you.
To conclude, combining SAST, DAST, DevSecOps, and AI offers a comprehensive approach to secure software development. This layered strategy ensures early detection, continuous monitoring, and smarter threat response. Thank you. These are the publications and the references that we had gone through to create this report.